Today we're going to go over lot sizing, site selection, permitting, the loading criteria applied on structure, the structural design based on those loading criteria, cost estimates that finalize the design and engineering construction, and we'll close it up with summary and questions. But before that, Alstrom's. It's a 3-story reinforced concrete structure that houses a retail store and a cafe. We're going to give it off to Kyle, who's going to talk about the parking lot and lot sizing.
All right, thank you, Minh. So the reason why we need to determine our lot size is to find out the minimum space that we need to do our construction for our building, and with that we can pick the correct size of lot so that we don't undersize or oversize too much. The factors that we're going to do in determining the lot size, we have the building footprint, the parking lot size, which is determined through the area, the floor area of the building, and then the property line setbacks. And for our lot, the minimum size required is about 1 acre. So we need at minimum 1 acre to develop. If we have something more, we can sell the other part, but we can't have anything less. And now I was going to talk about the site selection.
Thank you. So as Kyle said, our minimum for area is an acre, so these all meet the requirements. Our first site is located at Berryessa and North Jackson Street. Our second is 5750 Santa Teresa Boulevard, and our third is 512 South Basement. The locations are highlighted in the yellow, as you can see. The things on the left are some of the parameters we use to decide our location. Some of the things we took into account more was proximity to highway and availability to public transportation. We did this because when a store is close to a freeway or close to transportation, it's more likely people are going to be seeing it and come to it. So we felt being close to a VTA or the freeway was better than being out in the middle of nowhere. And then our third most important thing was local median household income, which is 91, 105, and 79. This was important because we found that people that shop at Al Kebab's and Alstrom's makes a median income of about $85,000. So we figured the third one probably didn't meet our requirement, and then we went towards the price per acre, and it is Berryessa Road and North Jackson is better than the second one. So our decision was to choose the first site, which is Berryessa Road and North Jackson. And now Frank will talk about the permitting.
Thank you. To continue the presentation, I will talk about the permitting. But why we need to permit? Because when we do something else, we need to ask somebody allow us to do the job. So we need the permit to ask the city or to allow us to do the job. And the first thing we have to blending review to see what the architecture drawing, how the building something like that. And the second thing, we need to check the environment impact report, because if we don't pass environment impact, we cannot do the job. The third thing, we do the community public voting. The next thing is to public work. And the fifth, we have building and fire plan, because this one very important for us for the building, because if we don't take care of the good fire plan, so if the building plan or damaged, the fire cannot go to help or make the people die. The last thing is we make a building permit, and then we will transfer to the lot criteria for Minh.
Thank you, Frank.
You're welcome.
So, we're going to talk about the loading criteria on the structure. So 3 things we considered: dead load, live load, and rain load. Earthquake loads, wind loads, and various other loads were not considered in this design. For the dead load, we considered the deadweight members that include flooring, ceiling, panels, and steel wires to hold those. And the concrete members themselves: walls, parapets, beams, slabs. For the live load, we considered, we used ASC's section, chapter 16 to determine that there were multiple concentrated loads, and in an equation that they have, divide 1,000 by a square area of 2.5 by 2.5 feet to determine a loading per square footage. And then the rain load was calculated using the ASCE and IGCs in chapter 17. And we calculated these values, and we factored them using ACI 318 to arrive to these values. Now we use these values, we plugged it into a SAP model to determine max moments, max shears, so that we could design the beams along this section. 3rd floor on the right side of the front view. Here we have the support and the beam going along the right side section. In the red, we have the slab reinforcement, the green, the shear reinforcement, and in the black here, we have the positive moment reinforcement and the negative moment reinforcement. We have 6 number 10 bars in tension, and in compression, we have two number 9 bars being spliced here and extending into the support, and also extending into the support on the opposite end. The 70 inches comes from chapter 12 of the ACI code, and that's the development length, whereas the 122 inches comes from 2 times the development length minus the depth of the beam. And these are cutoff lengths that are calculated to determine how far the bar should extend before, or so that they should meet flexure requirements. Here's a cross section of MM, 6 number 10 bars using number 3 stirrups, and 2 number 9 bars at the bottom, with a spacing of 3.6 inches for the splicing, and a beam thickness of 22 inches, and a spacing of 3.9 inches from the center of reinforcement to the center of the middle reinforcement. Now I'm going to hand it off to Frank, who's going to talk about the shear reinforcement.
To continue structural design, I talk about a stair. We use a stirrup from the side. We use stirrup number 3 bars, and the first stirrup we put at 4.5 inch from here, and then we continue to put 19 stirrup at 9.5 inch from the here to the continue down. And then I will transfer next to Yip to talk about the slab design.
So I was responsible for the slab design. Since we're doing slab number 17, which is the middle of the front frame, we can't use the coefficient method because the span here to the next span is out of 20%, so we have to use SAT modeling. And from there we got the moment, and then we use that moment to calculate the amount of spacing we need. So for the main reinforcement along the short side is approximately using 6 bars, 11 inches, and for the temperature reinforcement, we use number 3 bars at 11 inches, which is all under 18 and the additional code requirements. and I'll give it next to 9 for the column.
Thank you. Alright, so the column that I'm going to discuss is located C1, and it's between the third floor and roof. The first thing we calculated when we were calculating this was to make sure that it was a short column. The next thing we calculated was the splicing length between the bars, as you can see right here. And then here's the section AA, which represents the cross section of our column. There's 8 number 11 bars, and then there's 4 number 4 bars. The 4 number 4 bars were put in there because we needed a clear cover of 6 inches for additional ties. Our cover on both sides was 2.5 inches. And then going back to the column, for our ties, we put our first tie right here, located at the face. The next tie up was S/2, which is 11 inches. And then every other tie was 22 inches from there. And at the top of the column, we have a clear cover of 2. From ACI, we need at least a 1.5 cover. And now I'll pass it on to Kyle, who's doing footing. Oh, sorry. This is the representation of our splicing. These black circles represent that.
Okay, my name's Kyle. I'm going to talk about the footings. So the footings are a way to distribute the loads on the building to the ground. And here we have a plan view of our design footing. It's going to be a rectangular footing. It's going to be a spread footing, so that means it's a shallow footing. And they're going to be placed at the bottom of each column. Now to determine the area of the footing, we used data from the boring logs from the site. The site told us that we had a granular soil underneath the footing, and it gave us support of about 3 kips per square foot. Subtracting the weight of the footing, it gave us a net allowable of 2.02 kips per square foot. And so we were able to determine the area of the footing that we need to support, which is a 10-foot by 15-foot footing. Right here. So, and then also for the design of the footing, we used a 30-inch deep footing, and that will help us counteract the shear that is imposed upon the footing right here at the base of the support. Also, too, finding the moment within the footing. There's 2 ways. There's 1 way and 2 way. 1 way was right at the base of the support. 2 way was at a distance, and we were able to find the main reinforcement for the footing. The main reinforcement for the footing is number 8 bars, and the number 8 bars going in this direction. I think it's actually 4/5 of it was within a distance deep from the support, and then the rest, 1/10 and 1/10, were right in the middle of the remaining distance. And then the reinforcement going longitudinally was evenly spaced. Also, too, the loading transfer between the column and the footing required dowel bars. The dowel bars, calculated, we used about 4 number 8 bars. Those had to be developed both into the footing as well as into the column, and we have 26 inches into the column. And Dib's going to talk about the process.
This is the basic cost estimate. The total of engineering is about $1,100, and the cost of materials totals to 157,000, and the total cost estimate is around 8.6 million with annual income of 430,000. And you can expect at least a rate of return within 20 years for the best lot, which is the Berryessa at North Jackson. And we'll finish it
To
up.
include, Hallstrom's Emporium retail store and Off-Box Cafe is located at will be located at Berryessa Road and North Jackson Avenue in San Jose, California, with a total construction cost of $8.4 million and a return of 20 years. After that 20 years, you'll be making about $430,000 a year, and this investment will make you happy and end up here. Thank you, Mr. McCoy and Dr. Almanacir. Any questions?